the 10 kilometer run. And so what I always suggest is that you look in the problem and look for the information that's written down. Now notice I'm writing 10.0 kilometers just like the problem says, because we've got 3 significant figures there and we want to hold on to them. On your PowerPoint, it also gave the conversion factor, which I apologize, I didn't give to you here. The conversion factor is that 1 mile is equal to 1.6. Whoa, what happened? Let me wonder what in the world happened there. All of a sudden, my pen started writing really thick. All right, and so, okay, so hopefully I've got that. That's 1.609 kilometers. So this is our conversion factor. So that's what we're going to use as one of those conversion factors or fractions, all right? Now, whatever you started with, of course, you can put that over 1 or X or a smiley face, whatever you want. It doesn't make any difference. It's just going to be a placeholder. And then you're going to write your conversion in so that your kilometers are going to cancel. So right away, you should know then where the kilometers go. And that's going to give us miles. Another way to know that you need miles on the top is that whatever unit you're looking for, you put on the top. And then you simply just look at your conversion. 1 goes with miles, and we don't count significant figures in these conversion factors. It's an infinite number of significant figures. 1.000 would be what the miles is. Then 1.609 kilometers. And then, just like the directions said, you go straight across the top, and you're going to multiply these things together right across the top. So 10 times 1, of course, is 10, and that's still 10.0. We're still holding on to those 3 significant figures, and those are miles, units of miles. On the bottom, the only thing that you have is 1.609 because you had that placeholder. And now you're going to do the math. 10 divided by 1.609, and that's going to give you 21504, and it just kind of keeps going for a little while. And I know, of course, that my measurement had 3 significant figures. We don't count those for our conversion factors. And so I'm going to need to cut this number at 3 significant figures. And so now, right now, I've got it down to 4. And so I can see that I'm going to have to round this 2 to this 1 to a 2. So we're talking about 6.22 miles. For this person that's going to run that 10-kilometer run. So take a look at that and compare it with how you did. Next example is example 2. How many gallons are in an 8.7 liter jug? Now, once again, you do need that conversion factor. So as you're reading the problem, what's the first thing you're going to do? If you said, I'm going to take a look at what's given in the problem, and I'm going to write it down. We have an 8.7 liter jug. You can put that over 1, an X, a smiley face, whatever you want. That's just a placeholder there, so that when you're taking a look at your conversion factor, you'll be able to do those correctly. And I didn't give you the conversion factor here, but it is right in the problem. Is 3.785 liters to 1 gallon. So if you're going to write that as a conversion factor, where are you going to put your liters? You need to put it somewhere so that they're going to cancel out. Exactly. So if you were thinking, okay, we're going to put 3.785 liters here on the bottom and 1 gallon at the top, you are exactly right. And now we simply do the math. So we go straight across the top. We multiply these 2 together. So we know that 8.7 times 1 is 8.7, and the units there that aren't canceled out are gallons. Now, of course, we can go straight across the bottom, and we're going to multiply these together. 1 times 3.785, of course, is 3.785. We have no units on the bottom. And now we do the division. 8.7 divided by 3.785, of course, gives us 2.298546896, and those are gallons. Well, again, we don't count significant figures from our conversions. So we've got to cut this down to 2 significant figures. So I'm going to need to get rid of all these other numbers that the calculator spit out. And I'm going to need to round that, of course, to 2, instead of 2.29, 2.2 gallons. And so there is our answer. So now we know that if we have an 8.7 liter jug, it's only 2.2 gallons. Question asks how many miles per hour are in 452 meters per second. We've got 2 conversion factors here. We've got that 1 mile is equal to 1,609 meters. That's a 0 right there. And we know that 1 hour is equal to 3,600 seconds. All right, so once again, you're going to do this problem the exact same way as we've been talking about. And what you're going to do is take a look at what the problem gives you and write it down. And now we're going to look at our first conversion factor. We've got meters to miles. So we're going to need to write our conversion factor down, meters and miles, so that our miles will cancel out. So if you were saying, oh, I need to put those miles down there, or I'm sorry, those meters down there, 1,609 meters is 1 mile. Now, of course, your meters are going to cancel out. Now, you can go ahead and figure out what that equals, or you could go ahead and do the next conversion. Because our next conversion, of course, is hours to seconds. And we've got our seconds on the bottom, and so we're going to need our seconds to cancel out right up there. So we would make this say 3,600 seconds is 1 hour. Now we're going to do just like we've been doing all these other times. We're going to go straight, and we have more things now because we have 2 conversions in the same problem. We're going to go straight across the top and multiply these. So 452 times 1 times 3,600 is equal to, and I'm not going to cut off any significant figures yet. That's what I do at the end. 1627200. And I'm going to put my decimal place there to hold on to all of those significant figures. And those are miles. If we take a look, we're going to go straight across the bottom. We're going to multiply these together. So that's 1,609 times 1 is 1,609 hours. And now we can simply do the division here. We're going to take the top and the bottom and divide them. So 1627200 divided by 1,609. And you've got 1,011.311374. I don't even have room for my units. So let's look back at our original problem. 3 significant figures. So we're going to need to cut this down to 3 significant figures. So that's going to be kind of easy. So I'm simply going to change that 1 to a 0. Whoops. All right. And our units, they're going to be just coming right along for the ride. We've got miles on the top, hours on the bottom, as you can see. And there we are. Somebody who is going 452 meters per second is traveling 1,010 miles per hour. So I wonder if they can continue going. Go a little bit longer. All right. So one of the things we were going to get into tonight, and we didn't get a chance to, but I will touch base on it on next Tuesday, and you can be reading about it in your textbook as well, is density. And density of water is 1 gram per centimeter cubed. And so as you're taking a look at that, of course, you should be thinking, let me write that down. I don't need to put it over 1 because I have centimeters cubed here in my denominator. And I'm trying to figure that out in pounds per cubic feet. And so I see I didn't give you any conversion factors, so I will need to do that as well. Obviously, on a test or a quiz, you would always be provided with those. All right, so I'm going to try to turn this into pounds per foot cubed. All right, so let me go ahead and give you those conversion factors here, because 1 pound, you're going to need to know, is 453.592 grams. So we're going to want to write that as a conversion factor so that we can have our grams canceling out. So if you're thinking, oh, I want to have this 453.592 grams right there on the bottom. And with that, I'm going to put 1 pound. And then, of course, our grams are going to cancel out. So we could stop there and figure that out and then do another conversion, or we can just keep right on going. Because the other thing you needed to know was that 1 cubic centimeter is equal to 3.53 times 10 to the minus 5 foot cubed. So we can use this as our next conversion factor. Again, we want to cancel it out so that centimeters are going to cancel with centimeters. So we want to put 1 centimeter cubed there is equal to I'm going to take this out of scientific notation now, so I'm going to take this decimal point here, and I'm going to move it over to the left 5 spaces. 1, 2, 3, 4, 5. All right, so that's going to be, and I'm going to put each of those places, I'm going to put a 0. 1, 2, 3, 4, 1, 2, 3, 4. All right. And so there we've got 1 cubic centimeter equal to how many feet cubed, because that's what we're trying to go to. Notice that there are cubic centimeters are canceled out. And then we go straight across the top and multiply all these together. So what's 1 times 1 times 1? Obviously, that's 1. We've got pounds left at the top. And if we go across the bottom, of course, we had nothing here. 453.592 times 0.592. 453.592 times 0.0000353 is equal to, on the bottom, so if we go straight across the bottom and multiply those, 0.016011. Now we simply just do the math. 1 divided by 0.016011 equals, oh, and I should have mentioned that those are feet cubed. And so what does this equal? It equals 62.45 And those are going to be pounds per feet cubed. All right, and so how many significant figures? We're going to need to cut it to 3. So we've got 62.45, and that's a 7 after that if I look on my calculator. So as I cut that down to 3 significant figures, we're going to have to cut it right there. .5 pounds per square inch. All right. So I'm hoping that that helps you to understand a little bit better about how to do these dimensional analysis. I'm trying to think if we have another one. This is one that I always love because, you know, there are some doctors that think that your heart only beats like a certain number of times. So once again, as you're reading the problem, what should you be looking for? Right, the information to write down. And so you probably could do either one of those. I'm going to start with the heart rate because that seems to be what the problem is focused on to me. You would come out with the same thing if you did another, I mean, you could do, there's tons of things you could do. So I'm going to take a look at this as being 72 beats per minute. All right, and then I'm going to try to figure out some conversion factors. I've got to be able to get out of okay, there we go. So now we got 72 beats per minute. Well, we know that 60 minutes is 1 hour. So there we are. And so you can see there, oh, yes, so there we go. We've got my minutes canceling out. All right, and so now we got 72 beats per hour. But we're trying to get to a lifetime of 85 years. So we're going to need another conversion here. And the conversion we're going to need now is we're going to need to go hours to days because 24 hours is 1 day. And then we can keep on going because we know that our hours have canceled, so we're left with days. So 365 days, whoops, and that should say days, is 1 year. All right, and then we're going to multiply that by 85 years. So what I would suggest that you do is go straight across the top and multiply those. What's 72 times 60 times 24 times 365? And so if you were doing that math, you would have come up with 630,720. Our units are their days. All right. And then we've got nothing, 1, 1, 1. And we've got, let's see, our days canceled out, so we've got years. Oh, sorry, our days are gone. I don't know why I put them. It should be beats. My bad. You probably already noticed that and have yours correct. All right. And now we're interested in 85 years. So if we multiply this by 85 years, you can see that your years are going to cancel out. And so then we're going to be left with however many beats that's going to be, which is 5, 3, 6, 1, 1, 2, 0, 0. And that's how many beats that heart is going to make. All right, so if we take a look here at our problem, the least number of significant digits we have is 2. So we're going to have to cut this down to 2 significant figures. So if you look at your decimal there and then just move the number, move the decimal point over. That's what I'm going to suggest that you do here. And I'm going to suggest that you make that 5.4 times 10 to the 1, 2, 3, 4, 5, 6, 7, 7th power. I hope this helps as you're learning how to do dimensional analysis.